the light that already arrived. If you could ask the light currently touching your eyes when it left, it would say, now, not a few nanoseconds ago, not just now, the way you mean it. Now, exactly, no matter how far it travelled to get here. There's a weight behind the eyes at this hour. You know the one. Not tiredness exactly, more like the body deciding to stop asking questions for a while. That's fine. This idea doesn't need you fully awake. It might work better if you're not. A friend of mine runs a small channel called Sleepy Science, and somewhere in an old email someone asked a question that never quite left the building. Does light experience the trip at all? Not. How fast does it go? Whether there's a during in there anywhere. Here's the strange part, there isn't. Not. It happens too fast to notice. Not. It happens, but briefly. There is no during. From light's own accounting, and physicists really do talk about this as a legitimate accounting, one built directly out of special relativity. Departure and arrival are the same event, same instant, same point. The star died, and the photon reached your eye, and between those two things nothing happened. Not very little. Nothing. This is where most explanations rush in to soften it. I'm not going to do that yet. Let it sit there, slightly wrong-shaped for a minute. You already know that moving fast changes how time behaves for you. A clock on a plane runs a hair slower than a clock on the ground. Astronauts come back from long stints in orbit measurably younger than the version of them that would have stayed home. Fractions of a second, but real ones. Confirmed, repeated, boring by now to the people who measure it. That's time dilation, and it's not speculative. It's Tuesday afternoon physics. What almost nobody sits with is where that effect goes as you keep pushing the speed up. It doesn't level off. It doesn't approach some gentle asymptote and politely stop. As velocity climbs toward the speed of light, the rate at which time passes for the traveller drops toward zero, not slower, toward zero. Light doesn't approach the speed of light. It travels at it, always, everywhere, without exception, the moment it exists. So whatever that limit was creeping toward, the total stopping of a clock, light doesn't creep toward it either. It's just already there. A photon has no internal clock ticking down the miles. It has no interior at all, no proper time, no sequence of one moment and then the next moment after that. The whole 8-minute walk from the sun to your skin, the whole 13 billion-year walk from some galaxy near the edge of what telescopes can find. From the light's own perspective, if it had one, none of that has a length. It's zero. Every trip light has ever taken has taken it no time at all. Felt from the inside because there isn't an inside to feel it from. I keep wanting to call that impossible, and it keeps not being impossible. It's just what the equations do when you let velocity actually equal c instead of almost equal it. Sit with that for a second before we go further, because we will go further. There are questions buried inside this that take chapters, not sentences, to loosen. Where does a photon's beginning even live, if it never ages between its birth and its end? What does distance mean to something that experiences no gap to cross it in? Whether the oldest light in the universe is a phrase that even makes sense from the light's own point of view, or whether age is a word that quietly stops applying once you cross that threshold, the way wet stops applying once you're the water itself. None of that resolves tonight. I don't think it's supposed to. If a line like that catches on something for you, I'd be curious what it catches on. People leave guesses under these sometimes, and every so often one lands closer to where the physics actually goes than mine did at the start. And however this channel is still here, still finding its way into a search bar at 1 in the morning, some of that is just people choosing to stick around for it, which is its own small, unlikely thing, worth noticing before we move on. Because here's what stays with me, longer than the equations do. Everything you have ever seen, every photon that has ever landed on you, arrived having experienced no time at all getting there, while you, standing still, watching it land, experienced every second of the wait. The light didn't wait, you did. That asymmetry is not a rounding error or a trick of language. It's built into the structure of space-time itself, verified, unglamorous, sitting quietly underneath every beam of light that has ever reached anyone, including this one, including now. Nothing moves slower than this. Inside an atom, an electron does not travel from one place to another the way a marble would. It doesn't pass through the space in between. It's more accurate and stranger to say it exists as a kind of smeared possibility around the nucleus, and only becomes a location when something forces the question. I've read that sentence 100 times, and I still don't know if I believe it the way I believe a chair is solid. But something in that smallness sets a limit for everything larger than it, all the way up, and that part I trust more, because it doesn't ask me to picture anything. It just asks me to accept a number. 299,792,458 meters per second. In a vacuum. Exactly that, not roughly that. It's actually how the meter itself is defined now, which is a strange kind of circularity if you think about it too long, so don't. Nothing with mass gets there. Not almost nothing. Actually nothing. No matter how much energy you pour in. You could hand a proton the entire output of a star, and it would still fall short because the closer it gets to that speed, the heavier it effectively becomes, and the heavier it becomes, the more energy the next push requires, and the ratio never closes. It's not a wall you hit. It's a wall that keeps retreating exactly as fast as you approach it. Only things without mass get to travel at it, and they don't get a choice about it either. Light doesn't accelerate up to full speed the way a car does. It exists at full speed, immediately, the instant it exists at all, and it can't be any slower or faster than that under any conditions anyone has found. Not near a black hole, not in the coldest deep space, not anywhere. I want to say that's the rule and move on, but the rule is doing something underneath itself that I find harder to sit with the longer I look at it. This isn't really a speed limit on light. It's a speed limit on cause-reaching effect. It's the fastest that any information, any influence, any change in one place can possibly matter to another place. Light just happens to be the thing that travels at the limit, not the reason the limit exists, which means the limit was there before light was. It's baked into the geometry, into the actual shape of space and time knitted together, not into the light itself. That's the part that keeps surprising me back into paying attention, weeks after I first read it clearly enough to say out loud. Here's where it gets spatial in a way that's easy to miss. If nothing can outrun that limit, then no two points, however close, can affect each other faster than light could cross the gap between them, which means the universe isn't one single now happening everywhere at once. It's a patchwork of nows. each one only able to talk to the nows nearby at a rate the geometry itself refuses to exceed. A star could explode 10 light-years away right this second, at this exact instant sitting in front of you, and it would not be true. Not for you, not for anyone standing where you're standing, until 10 years pass and the light physically arrives to make it true. Not until we hear about it, until it becomes true here. That's the part that stops being about signals and starts being about the actual structure of what now even means, stitched differently depending on where you're asking from. I'm not sure I fully understand what that does to the word simultaneous. I don't think most physicists claim to either, not in the gut sense. They trust the math more than the intuition, and the math is unambiguous even where the intuition just kind of stands there. Zoom out further and the limit doesn't loosen. It tightens in a way. The observable universe, everything we could in principle ever see, has a hard edge defined entirely by this number and the age of everything. Light hasn't had time yet to cross the distance from certain places to us, and it never will, because the space between is stretching faster than light can close it. Some galaxies are not just too far to see, they are permanently, structurally unreachable, not because of some engineering failure on our part, but because the geometry itself has ruled it out. There's a boundary out there, invisible, silent, built entirely from one number and the amount of time that's passed since everything began, past which nothing that happens can ever, under any circumstance, reach us. Not now, not in 1 trillion years, not ever. I don't know a good way to end a thought like that, so I'm not going to try. Some limits explain themselves. This one just sits at the edge of things, quietly deciding what gets to exist for us and what doesn't, and it was doing that long before there was anyone around to notice, and it will keep doing it long after. What a clock cannot do at that speed. The reunion has already happened by the time this chapter starts. Two people who once stood on the same tarmac, said the same goodbye, are standing together again, and one of them has aged differently than the other, and neither of them fully knows what to do with that fact now that it's sitting in front of them instead of in a textbook. This is time dilation, and it's real, measured, unremarkable to the people who work with it daily. The effect isn't a thought experiment anymore, hasn't been for decades, not since clocks got precise enough to catch it happening in ordinary rooms. Atomic clocks flown on commercial airliners in the 1970s came back measurably out of sync with identical clocks that stayed on the ground, off by fractions of a microsecond, exactly as predicted. No drama, no controversy, just numbers lining up with equations that had been sitting quietly in physics journals since 1905. After that, forget the word. Just feel the shape of it. Picture someone strapped into a seat, hurtling around the planet at thousands of miles an hour, and picture their heartbeat. Patient and unaware, ticking through exactly as many beats as it would have ticked through sitting at a kitchen table, except it isn't exactly as many. It's very slightly fewer, a difference so small you'd need an atomic clock to catch it. But the body doesn't need to catch it to be living it, because the body was never asked to notice. It just carries the effect the way it carries everything else it doesn't understand about itself. Astronauts on the International Space Station orbit at roughly 17,500 miles an hour, fast enough that after 6 months aboard, they return having aged a few milliseconds less than the people who stayed on the ground waiting for them. Not a rounding error, a measured, confirmed, repeatable fact about two hearts that started on the same schedule and didn't end there. Now go faster. Go so fast that the fewer becomes noticeably fewer. Not laboratory fewer, but human fewer. Days fewer. Years fewer. And you're describing something that hasn't been achieved yet by any human traveller, but has been achieved repeatedly by particles, muons, created when cosmic rays slam into the upper atmosphere, given a lifespan of about 2.2 microseconds before they decay into other particles, a lifespan far too short by any ordinary accounting to survive the several-mile fall down to the ground at anything less than the speed of light. And yet they arrive, more of them than they should, detected in labs at sea level in numbers that shouldn't be possible if you only used their resting lifespan and the distance they had to cross. Slow down here. There is no over-language for what a muon is doing when it survives past its own expiration date. It isn't defying anything. It isn't racing the clock. It is simply experiencing less time than we are for the same journey, because the journey has more than one length, depending on who's asking, and asking from a place moving nearly the speed of light gets you a shorter answer every time. From the muon's own frame, barely any time passes at all during the fall. Its internal clock, whatever a particle's clock even means, is running so slow relative to ours that its normal 2.2 microsecond lifespan simply hasn't run out yet by the time it hits a detector. The particle isn't cheating physics. The particle is physics, working exactly as expected, in a regime too fast and too small for the kitchen table version of intuition to follow along. There's a second way to describe the exact same event, and it's worth sitting with both at once. From our frame, standing on the ground, the muon's clock is what's running slow, dilated, stretched, giving it enough extra ticks to survive the trip. From the muon's own frame, its clock is running completely normally. Instead, the atmosphere itself has gotten shorter, contracted down along the direction it's falling, so there's simply less distance left to cross before its short life runs out. Two different explanations, two different frames, the same outcome arriving at the detector, undisputed either way. Come back up to speed. If a muon can outlive its own clock by moving fast enough, then somewhere out past the edge of what we've built machines to do, a body could too. Not forever, not without limit, but meaningfully, differently. A version of aging that isn't slower everywhere, just slower relative to whoever stayed still. Twins really would stop matching. Not metaphorically, actually. One heart beating out its allotment at a different rate than the other, not because either heart is broken, but because they were never running on the same clock to begin with, and nobody warned them, because nobody ever really believes it until the tarmac. I keep circling back to the muon, though, more than the twins, more than the astronauts, because the muon didn't agree to any of it, didn't board a ship, didn't sign up for an experiment. It was made in a collision 30 miles above your head, and it simply lived exactly as long as physics allows something moving that fast to live, and physics allows more than you'd think, and that's the whole chapter, really. Not a spaceship, not a paradox, just a subatomic scrap of matter, outrunning its own short life by doing nothing except going fast enough that short stopped meaning what it meant a moment before. The space between two mirrors. You've probably heard that light takes 8 minutes to reach us from the sun, and that's true, and it's also the least interesting way to say it, because it treats the trip like a drive, like there's a road and a car and a clock ticking off the miles the way a clock ticks off miles for you or me. and there isn't. Not really. Not for the thing doing the travelling. Here's a version that sits closer to what's actually happening. Take two mirrors, perfectly reflective, and face them toward each other. Close, a meter apart, maybe less, and send a single pulse of light bouncing between them, back and forth, and just listen to what that's doing. Because it isn't silent in the way you'd think. It has a rhythm, a pulse of its own, a light clock. The same one physicists actually use to explain why time bends the way it does, and the rhythm of that bounce is steady, is reliable, is the closest thing to a metronome that the universe hands you for free. Now move the whole apparatus. Not the light, the mirrors, the frame, the room they're bolted to. Slide the entire thing sideways at some enormous fraction of the speed limit, and watch the bounce again, except now the light isn't just going up and down between the mirrors anymore, it's going up and down and also sideways, tracing a longer diagonal path each time, a zigzag instead of a straight line, and it still has to cover that longer path at the same fixed speed, because that speed never changes for anyone, ever, no matter how fast the mirrors are moving, which means each bounce takes longer. Not a little longer in the sense that we'd need to squint to see it. Longer in a way that adds up, tick by tick, into an actual measurable slowing, and that slowing is the whole trick. That's the entire mechanism sitting underneath every twin paradox thought experiment you've ever half followed. It isn't magic. It's a zigzag. It's geometry doing exactly what geometry does when you stretch a diagonal instead of a straight line. Sit inside that bounce for a second. Feel it, not as an equation, but as a sound. A low tick, then a longer tick, then a longer one still, the rhythm stretching out the faster the mirrors move, until at the speed of light itself the tick simply never completes. The bounce never lands. There's no second click to answer the first one, which is another way of saying what earlier chapters already said in a different shape. No interior clock, no interval. No gap between the first mirror and whichever mirror light thinks it's heading toward. Layer something else on top of that, quietly, without comparing it to what just came before. The zigzag path isn't just longer in an abstract geometric sense. It's longer in a way that depends entirely on how fast the mirrors are moving relative to whoever's watching. Someone riding along with the mirrors sees the light go straight up and straight down, the same short bounce it always was. Nothing strange at all from where they're sitting. It's only the observer left behind, watching the whole rig slide past, who sees the diagonal, who sees the stretched path, who sees the slowed tick. Two people, watching the same two mirrors, describing two different bounces, and neither of them is wrong. That's not a contradiction to be resolved. It's just what happens when you stop assuming everyone shares the same clock. Let that settle without reaching for the next idea yet. There's no hierarchy here, no version of the story that's more true than the other. The person riding with the mirrors isn't missing something the outside observer sees clearly, and the outside observer isn't being fooled by some optical illusion the insider is immune to. Both descriptions are complete, exact, and internally consistent. They simply don't have to match each other, because how long did that bounce take was never a question with one universal answer waiting to be discovered. It only has an answer once you specify who's asking, standing where, moving how fast. What settles here, underneath all of it, layer by layer, without needing to be compared to anything else. distance and duration were never actually the same kind of measurement, not fundamentally. They only look like the same thing when everyone involved is moving slowly enough that the difference doesn't show up at the numbers you'd bother writing down. Faster than that, and the two come apart completely, the way two things that always arrive together finally reveal that they were never actually glued. The hallway doesn't have a middle. It only has the two mirrors and whatever's bouncing between them, ticking out a rhythm that means something different depending entirely on how fast you happen to be moving while you listen to it. Where the photon keeps its beginning. Start as far away as this can go, not light years away, further than that in a sense because the distance that matters here isn't measured in space at all. Start with the fact that somewhere, right now, a person is standing outside on a clear night doing something almost nobody stops to think of as an act of measurement, looking up. They think they are looking at stars. They are not quite. They are looking at reports, old ones, some of them so old that the thing that sent the report finished existing before the report arrived, which means the sky, in a very literal and unglamorous sense, is not a place. It's an archive. That's the wide frame. Hold it a moment, because it's going to close in fast, and it's going to close in on something that doesn't behave the way an archive should. Every photon in that sky left its source at some specific moment, and every photon in that sky is arriving at some other specific moment, and between those two moments, sometimes minutes apart, sometimes millennia, sometimes numbers so large they stop being intuitive and start being just symbols on a page. A certain amount of time has passed. We can calculate it. We do calculate it routinely in university astronomy departments without anyone finding it especially strange anymore, the way nobody finds it strange that a letter takes 3 days to cross an ocean, distance divided by speed. Nothing exotic about the math itself, except the last chapter and the one before it already put a very inconvenient thought into the room and then declined to deal with it. Time dilation doesn't taper off gently as you approach the speed of light. It goes to zero, not close to zero, all the way there at the actual limit, which light actually reaches, unlike literally everything else made of anything, which means if you take the equations at their word rather than rounding them off out of politeness, a photon experiences no interval between the moment it's emitted and the moment it's absorbed. None. Not a very short one. None. So which is it? Does the light take 14 billion years to reach us? Or does it take no time at all? Both. At once. Depending entirely on who you ask and depending on nothing else. Not on the light itself changing. Not on some deeper truth hiding beneath one answer that makes the other one false, but on the fact that duration was never a single, universal, agreed-upon quantity to begin with. It only feels like one because everyone you've ever met has been moving slowly enough relative to each other for the disagreement to stay too small to notice. Light doesn't get that mercy. Light sits at the one speed where the disagreement stops being small and becomes total. From where we stand, the trip is real. It's long, it's dated, it shows up on calendars and in astronomy textbooks with commas in the numbers. 14 billion years, give or take, for the oldest light we can currently detect. Light released not long after the earliest moments of the universe itself, back when everything was a hot, dense, nearly uniform soup of particles too energetic for atoms to even hold together. That number isn't poetic license. It comes from redshift measurements, from the way the wavelength of that ancient light has been stretched by the expansion of space during its journey, stretched so far that what was once visible light now arrives as microwaves, a residue we can point instruments at and actually receive. The cosmic microwave background, not a metaphor for the early universe, a photograph of it, arriving late. From the photon's own accounting, if it is even fair to say a photon has an accounting, and this is exactly the point where I start to feel less sure of my footing than I did a paragraph ago. There was no 14 billion years. There was no waiting. There was no in-between at all. It left, and in the same breath. Without any breath actually passing, it arrived. Its own proper time, the quantity relativity uses to describe duration, as experienced by whatever's doing the travelling, is exactly 0 for any journey light ever takes, whether that journey spans a foot or spans the visible universe. The length of the trip from light's side of the ledger is not a small number, it's not any number. The concept of how long the trip took simply fails to apply, the way asking how heavy a shadow is fails to apply, not a hard problem, a wrong question, which puts us somewhere uncomfortable, and I don't think there's a way around walking through the discomfort rather than past it. If the photon experiences no interval between its birth and its end, then in some sense, and I want to be careful with how much weight in some sense is being asked to carry here, the photon's birth and the photon's end are the same event, not close together, the same. Whatever happened at the star, whatever happens when it strikes your retina or the sensor of a telescope, from the photon's own frame, those aren't two things separated by an unfathomable stretch of years. They're one thing viewed, absurdly, from two different addresses in time by everyone who isn't the photon. Try to hold both of those at once. An event that took 14 billion years, and an event that took none, and it's the same event correctly described both ways, with no version of reality quietly cheating to make the numbers agree. They don't need to agree. That's not a flaw in the theory. It's the theory working exactly as intended, in a place most of us are never forced to notice it operating, because we don't move anywhere near fast enough the disagreement to matter to us personally. Contract the frame in again. Down past cosmology, past redshift, down to a single photon, one specific packet of light, leaving one specific atom in one specific dying star. Ask, as plainly as the question can be asked, when did it begin? And the honest answer is that the question doesn't have the kind of answer it's expecting. When is a question built for things that live inside time, that move through a sequence of moments, that have a before and an after separated by something. The photon doesn't have a before and after separated by anything. It has an emission and an absorption, full stop, with the entire cosmic history in between belonging only to the rest of us. The ones still burdened with clocks, still required to wait, still standing outside on a clear night looking up at what we insist on calling stars. I keep wanting to find the sentence that resolves this, and I don't think that sentence exists, not honestly. Physicists will tell you the math is unambiguous, and it is. The derivation isn't in dispute. It falls straight out of special relativity, textbook material, decades settled. What's less settled, what maybe was never meant to be settled, is what to do with it once you've let it all the way in. Because it means every photon that has ever reached you, every bit of light your eyes have ever registered across an entire lifetime, arrived at you having, in its own terms, just been born, not aged, not travelled, just born, an instant ago, no matter how many years the number on the page insists it's been carrying. You're the one who waited, it never did, and the sky above whoever's standing outside tonight is doing the exact same thing. It's always done quietly, without asking permission, showing them a wall of instants layered one behind another, going back almost to the beginning of everything, each one arriving as if newly made, none of them older than the second before, and every single one of them, without exception, telling the truth. A universe with no middle. A telescope somewhere is already collecting light that has nowhere else to be. It's been falling toward that mirror for longer than there have been mirrors, longer than there have been eyes, and it just happens to land now, on this particular Tuesday, in this particular instrument, because that's simply where its trajectory ran out. I think about this more than is probably useful. The oldest light we can see left its source when the universe was a fraction of its current size, hot, dense, opaque in every direction, nothing like the dark and roomy place we're used to picturing. That light is called the cosmic microwave background, and I'm only going to say that name once because the name isn't the interesting part. The interesting part is what it's doing to the idea of old. We call that light ancient. 14 billion years, roughly, since it started its trip, and that's not wrong exactly. But the last chapter already cracked this open a little, and I don't think it fully closes back up. The photon making that trip doesn't experience 14 billion years. It doesn't experience anything. No aging, no waiting, no interior calendar ticking down the distance. Whatever old means, it isn't happening to the light. It's happening to us, the ones standing still, watching something arrive that never, from its own accounting, went anywhere at all. So when someone says we're looking at the early universe, what they mean is something stranger than it sounds. We're not looking backward in the sense of watching an old home movie, some faded reel slowly replaying itself. We're receiving something that, in its own terms, just happened. The photon isn't a message from the past. It's a message that has no past, delivered into a room that's had 14 billion years to get ready for it. Here the thought slows down, and I want to let it, because rushing past this part loses something. Picture the early universe, plasma hot, packed too tightly for light to travel more than a short distance before scattering off some charged particle, over and over, trapped, unable to get anywhere. A fog, essentially, made of everything that would eventually become atoms, stars, the elements inside your own body. Then, about 380,000 years in, the universe cools just enough. Electrons and protons combine into neutral hydrogen. The fog lifts. Light, for the first time, is free to travel in a straight line without immediately colliding with something. That moment of first freedom is what we're catching right now in that telescope, in that particular Tuesday. Not a memory of it, not a recording. The actual light itself, unaltered in its own reckoning, arriving having taken from its sides no time whatsoever. Recover the pace a little. What this means, if you let it mean something, is that the universe doesn't have a middle the way a story has a middle. There's no vantage point from which now is uniformly true everywhere at once, some cosmic present tense shared by every star and every observer simultaneously. Everyone is only ever looking at layers, this star as it was, that galaxy as it was, that background radiation as it was, at whatever moment its particular light happened to set out, stack enough of those layers, and you get something that looks, from here, like a timeline. But it was never a timeline out there. It's a timeline only once it's been assembled here by us, the ones doing the waiting. The universe doesn't have an age it's currently at, in the sense of a single number everyone agrees on from every vantage point. It has an age here, a different age technically everywhere else, depending on how far the light had to travel to make the report. I keep circling back to this because it undoes something I didn't realize I believed until I noticed I no longer could. That there's a now out there, universal, ticking the same way everywhere, and we're just catching up on old news from far away. There isn't. There's only ever the news that's finally arrived, layered over other news that arrived earlier, layered over other news that hasn't gotten here yet, and for some of it, never will. Somewhere, right now, that same telescope keeps collecting. It doesn't know it's catching the beginning of everything. It's just catching whatever happens to be falling into it. The universe doesn't announce which of its light is significant. It just sends all of it, indiscriminately, and lets whoever's listening decide what to call old, the distance that isn't there. Start with a single photon, not yet moving, the instant before it's released from an excited electron dropping to a lower energy state inside some atom, somewhere, anywhere. The exact mechanism that makes essentially all visible light in the universe, from candle flames to distant quasars, come into being in the first place. Now it's moving, instantly, fully, at the only speed it's ever going to have, with no gradual ramp up the way a car pulls away from a curb. One instant it doesn't exist, the next it exists at full speed, and that's simply how photons are born. They don't get a childhood. From here, ask the question that special relativity actually answers, cleanly, without hedging. How much distance has that photon covered, from its own point of view, by the time it strikes something and stops being a photon at all? Gets absorbed, ends its run, whatever length that run happened to be from the outside. 0. Not an extremely small number that we round down for convenience, not a distance too tiny to matter, but exactly 0, arising directly from a piece of special relativity called length contraction, which says that distances measured along the direction of travel shrink for anything moving relative to what's doing the measuring, more and more the faster it goes, until at the speed of light, a speed only light and other massless particles actually reach, the contraction becomes total. The entire path, whether it's the width of a room or the diameter of the observable universe, collapses down to nothing at all in the photon's own frame, which means, from the photon side of things, and I don't think there's a gentler way to say this, so I'll just say it, there is no journey. Origin and destination are the same point in space, exactly as they're the same point in time, which the last chapter already got partway toward, and this one is only now finishing. Widen it slightly. Consider that this isn't some special exception carved out for extremely long trips across the cosmos, some cosmic scale loophole that only kicks in past a certain distance. It's true for every photon, everywhere, always, the one crossing your kitchen just as much as the one crossing a supercluster. Because the contraction isn't a function of how far the light happens to be going. It's a function of how fast it's going, and photons only ever have the one speed available to them. Widen further, and let the geometry of this settle in properly, because it's easy to hear the distance is zero as a kind of poetic flourish, and much harder to actually sit with it as the literal, unremarkable output of an equation that has been tested more times than almost anything else in physics, across particle accelerators and satellite clocks and long baseline astronomical measurements that all quietly agree with each other in a way that stopped being interesting to physicists decades ago precisely because it kept working. So the 8 minutes the sun's light takes to reach your skin, the 14 billion years the oldest background radiation took to reach that waiting telescope, the picosecond it takes a photon to cross this room, every one of those numbers describes the trip only from the outside, only from a frame of reference where distance and duration still behave the way your whole life has trained you to expect them to behave. From the inside, if there's an inside at all worth talking about, there was never a trip to begin with. There was never a there that was different from here. The photon didn't travel across the universe. In its own accounting, the universe folded shut around it so completely that departure and arrival occupied the identical point, and everything in between, every star it passed, every dust cloud it grazed, every billion years it apparently spent doing so, belongs entirely to us, to the one standing still enough to have a story with a middle in it at all, held still inside motion. There's a moment right before you say it out loud when a fact still feels wrong. This is one of those facts. The fastest thing that exists doesn't experience its own speed. Not slowly, not quickly, not at all. Say it plainer. Light isn't rushing anywhere. From its own side, it isn't going anywhere. It's simply present, at both ends of whatever we call its journey at once. We keep the word travel. We probably shouldn't. Travel implies a route, a pace, some experience of covering ground. Light doesn't cover ground. It occupies 2 points that we insist on separating, and it doesn't recognize the separation. Think about what that does to speed itself, as a concept. Speed is distance divided by time. Take away the interior experience of both distance and time, which is exactly what happens at light's own frame, and speed stops meaning anything from the inside. It's a description that only works from outside the thing being described. A speedometer needs a driver who's living through the drive. Light isn't living through anything, so light is fast for us. It isn't fast for itself. It isn't anything for itself because there's no itself. Moving through moments the way you move through moments one after another, each one waiting its turn. Go back to the mirrors from a few chapters ago, briefly, because there's something in them worth revisiting from a different angle. Slow the bounce down enough, in your head, and you can almost picture light as a tiny traveller, patiently going up, patiently coming back down, living out a small life between two reflective walls. That picture is useful, and it is also completely wrong, in the same way a map is useful and also isn't the territory. The traveller in that picture needs a patiently. Light doesn't have one available to it. This is the part that lands somewhere close to the body if you let it. You are right now experiencing a very small but real amount of time passing between one word and the next. Your heart is doing something. Your lungs are doing something. None of it stops. None of it holds still. Everything about being alive is defined by things happening in sequence, one thing after another thing, endlessly, until it isn't anymore. Even at rest, even doing nothing, your body is a machine built entirely out of sequence. Blood moves, cells divide. A signal travels down a nerve and arrives a fraction of a second after it left, because everything in you is slow enough, compared to light, to actually have a fraction of a second worth talking about. Light doesn't get a sequence. It gets one instant doing the job of infinite instants, stretched from outside across whatever distance separates its beginning from its end. Nothing about it is paused, and nothing about it is rushing, because both of those words assume a clock is running somewhere inside the thing you're describing, ticking off a before this and an after this, and there simply isn't one to consult. There's a particular kind of stillness in a body that has stopped bracing for something, the way shoulders drop once a sound you were waiting for finally happens and turns out to be nothing. That isn't quite what this is, because bracing implies a before and an after, a tension building toward release. Light doesn't build toward anything. It's simply already at whatever the far side of that release would be, without ever occupying the tension in between. Held still inside motion. That's the strange center of it. Not frozen the way ice is frozen, not paused the way a video is paused. Just outside the category that moving and still were built to describe in the first place. Because that category assumes time is passing for the thing you're asking about, and for light, nothing is. Consider what it would take to actually catch light being still, in some experimental sense, and notice that the very idea falls apart before you can build the apparatus. You cannot ride alongside a photon and watch it hover, because riding alongside it requires a frame of reference moving at the speed of light, and no valid frame of reference exists at that speed. Special relativity doesn't merely fail to describe what light experiences, it refuses the question outright, the way a ruler refuses to measure temperature. It isn't the wrong tool used badly. It's a tool with no possible grip on that particular job. I don't think there's a comfortable place to leave this. Every photon that has ever reached you did so while, in some sense that's hard to hold on to for more than a few seconds at a time, not doing anything at all, not moving, not waiting, not aging, just being in two places that we experience as far apart and it experiences as exactly the same place, the whole time, without a whole time to speak of. There's an odd comfort in noticing how ordinary this is, despite how it sounds. You have never once in your entire life watched light take its time. You've watched shadows move. You've watched a sunrise arrive gradually, colour creeping up from the horizon over the better part of an hour. None of that gradualness belongs to the light itself. It belongs to the rotation of the planet you're standing on, the geometry of how much sky's uncovered minute by minute. The photons doing the actual illuminating at each individual instant did their entire job in what amounts to no time at all, over and over, arriving fresh, each one indifferent to the ones that came a second before it. Somewhere in a lab, right now, someone is measuring the arrival time of a laser pulse down to a trillionth of a second, and the measurement will be precise and useful and entirely about the observer's side of the story. The light itself has no story to tell about the interval. It never had one to lose. There's a version of this that shows up in ordinary technology, not just thought experiments, and it's worth pausing on because it makes the whole idea stop feeling theoretical. GPS satellites carry atomic clocks, and those clocks have to be corrected constantly for the fact that time runs slightly differently for something moving fast in orbit than for something sitting still on the ground. Skip the correction, and the system drifts by several miles a day. Not a rounding error, a navigation failure. Engineers don't debate whether relativity is real. They just build it into the software, quietly, the way you'd build in a correction for temperature or humidity. Light itself needs no such correction, because it isn't sitting anywhere between two ticks waiting to be adjusted. It has no ticks to adjust. The formal way physicists say all of this is that there's no valid reference frame moving at the speed of light. The equations of special relativity include a factor that grows without bound as speed approaches light speed, and at light speed itself, the math simply refuses to produce an answer, the way dividing by 0 refuses to produce an answer on a calculator. That's not a gap in our knowledge, waiting for a cleverer theory to fill it in later. It's a hard boundary built into the structure of the equations themselves, telling you, bluntly, that the question, what does a reference frame moving at light speed look like from inside, isn't a hard question with an undiscovered answer. It's a question the theory declines to ask in the first place, because nothing in the framework of special relativity is built to be asked from that vantage point. The two lightning strikes that disagree. Two lightning bolts strike at what anyone standing exactly between them would swear is the same instant. That's the whole setup. It sounds too simple to hide anything. Now put someone on a train, moving steadily past that midpoint at the exact moment the bolts strike. Not fast by cosmic standards, fast enough for the thought experiment to matter, which turns out to be surprisingly slow. Ask the person standing at the ground, did the two bolts strike at the same time? Yes, unambiguously. Light from both strikes had equal distance to cross to reach them, and it arrived together. So together is the honest word. Ask the person on the train the same question, and here's where something breaks that nobody expects to break. Because the train is moving toward one bolt and away from the other, the light from the bolt ahead has less distance to cross to reach the passenger, and the light from the bolt behind has more. The passenger isn't wrong to trust their eyes. They see one flash first, genuinely first. Not a delay caused by the train, not an illusion to be corrected for. An actual physically real disagreement about which event happened before the other one. Einstein wasn't chasing a curiosity when he built this. He was trying to reconcile two things that seemed to flatly contradict each other, that the laws of physics look the same to any observer moving at constant speed, and that the speed of light stays fixed no matter how fast the observer measuring it happens to be moving. Holding both of those at once, without cheating, forces simultaneity to give way. There's no version of the theory where you keep a universal now, and also keep light speed constant for everyone. Something had to give, and it turned out to be the thing nobody had thought to question. This is Einstein's own version of the thought experiment, more or less, built in 1905 to make an uncomfortable point as plainly as possible. Simultaneity isn't something the universe hands out for free. Two events can be truly, correctly simultaneous for one observer, and truly, correctly not simultaneous for another. And neither of them is making an error. Neither of them needs correcting. Both accounts are final. It would be easy to file this under optical illusion and move on, the way you'd file away the fact that a straw looks bent in a glass of water. It isn't that. The straw is actually straight. Your eyes are just being fooled by refraction, and a better instrument would tell you so. There is no better instrument here. There is no hidden true order of events that the train passenger simply failed to detect. Relativity doesn't say the passenger's clock lied to them. It says order itself. For events separated by distance is not a fixed property of the universe. It's a property of who's asking and how they're moving while they ask it. It's worth being honest about scale here, because the thought experiment can make the effect sound bigger than it is at ordinary speeds. A train moving at a normal, boring 100 miles an hour produces a disagreement about simultaneity so small it would take instruments far more sensitive than anything in daily life to catch it. Fractions of a billionth of a second, nothing your senses could ever register, nothing that changes a single decision you'll make today. The effect is completely real and completely negligible at once, which is exactly why nobody built an intuition for it. Evolution had no reason to hand you an instinct for something that never mattered at the speeds you evolved to survive. Sit with how much that unsettles, if you let it. Before and after feel like the most basic furniture of reality, older than physics, older than language probably. You assume, without ever needing to think about it, that if A happens before B for you, it happens before B for everyone, everywhere, always. That assumption works perfectly well for lightning strikes on the same street, for conversations across a room, for nearly everything a human being will ever personally witness. It fails precisely and provably once the events are far enough apart and the observers are moving relative to each other fast enough for the disagreement to become large enough to matter. Here's the part that keeps this from being just a curiosity about trains. It isn't only distant events that get scrambled this way. It's any pair of events that aren't causally connected, meaning no signal, not even light, could get from one to the other in time to have any effect. For those events, which one happened first simply isn't a question with one right answer anymore. Different observers, moving at different speeds, will order them differently, and the universe has no preference between their answers. It isn't hiding a correct order from anybody. There isn't one. This is where the earlier idea about light speed being a limit on causation, not just a limit on light, comes back around and finally shows its teeth. If nothing can travel faster than light, then two events too far apart for light to connect them in time cannot influence one another at all, in either direction, ever. And if they can't influence each other, the universe apparently doesn't bother assigning them a fixed order. Order, it turns out, isn't a background property of the cosmos, painted in before anything happens. It's something that only gets pinned down between events close enough, or connected enough, for one to possibly cause the other. There's a kind of relief hidden in this, if you look at it from a certain angle, though it took me a while to feel it rather than just understand it. It means the universe isn't secretly running one true timeline that we're all failing to perceive correctly. It means every observer's account done honestly, using real measurements and the actual finite speed of light, is complete. Nobody's watching a shadow of the real sequence. Everybody's watching the real sequence, their real sequence, and it simply doesn't have to agree with anyone else's when the events in question are far enough apart. This is also the piece that finally resolves something left dangling a few chapters back. The twin who ages differently, the reunion on the tarmac. For years, people raised what they thought was a fatal objection to that story. If motion is relative, why shouldn't the travelling twin be just as entitled to say it's the stay-at-home twin who did all the moving, and therefore the stay-at-home twin who should have aged less? The objection sounds fair. It isn't, and the reason is exactly this relativity of simultaneity. The travelling twin has to turn around to come home, and that turnaround is not relative. It's an acceleration, a real physically detectable change in motion that only one twin experiences. During that turnaround, the travelling twin's own sense of what's happening back home right now jumps, abruptly, in a way the stationary twin's never does. It isn't a paradox once you track that jump carefully. It's simultaneity, doing exactly what it always does, just doing it at a moment dramatic enough for someone to notice. Physicists have a name for the boundary that decides which events even get to have this argument. The light cone, the set of everything a given event could possibly have influenced or been influenced by, given how far light could have travelled in the time available. Inside that cone, order is fixed, agreed on by everyone no matter how they're moving. Outside it, order is up for grabs, genuinely, permanently, not because our instruments are too crude to settle it, but because there is nothing further to settle. Two events outside each other's light cones aren't waiting for better measurement. They're simply not the kind of pair that has a single correct order to discover. I don't think this resolves into anything tidy, and I'm not sure it's supposed to. It sits closer to the earlier idea about the sky being a patchwork of nows than it does to anything about photons directly, though it comes from the exact same well. Light sets the limit builds the patchwork, and somewhere inside that patchwork, two lightning bolts strike, and whether they struck together depends entirely on where you happen to be standing when they did, smaller than a question. So the light from a dead star isn't old. That's already been said a few chapters back, and it hasn't gotten any less strange with repetition. It isn't young either, not in any sense that would mean something to the star if stars had senses. Age is a word for things that live inside duration. A candle burning down, a body slowing, a battery losing its charge one measurable increment at a time. Light doesn't do any of that. There's no clock running inside it to slow down or speed up or simply stop. Ask how old a beam of starlight is, and you're asking a question built for something with an interior calendar, applied to something that never had one issued. What's left? Once you take away the story we usually tell about the trip, years crossed, distance covered, ancient light reaching young eyes, isn't a smaller version of that story. It's not a story at all. It's just the photon, arriving. Having, in whatever way having applies to something outside of time, done nothing except exist at one point and then exist at another point that isn't really another point. There's a habit worth noticing in yourself here, if you catch it happening. The instinct is to reach for a word like profound the moment a fact like this lands, and I'd rather not do that, because it isn't profound in the sense of being wrapped in meaning. It's just accurate. The universe doesn't owe zero-duration photons any drama. They're not being poetic when they arrive having experienced nothing. They're just doing what the geometry requires, the same way a stone rolling downhill isn't being dramatic either. Think for a moment about what this quietly does to the word ancient, a word this whole channel leans on more than almost any other. The cosmic microwave background gets called the oldest light in the universe, and it is, from where we're standing, genuinely the oldest thing we can detect. A faint glow left over from when the cosmos first became transparent to light at all. That much is not in question. But oldest is doing a job here that only makes sense from our side of the exchange. The light itself carries no additional weight of age compared to the light that left a lamp across the room a moment ago. Both travelled 0 duration by their own accounting. One simply had a much longer story assigned to it by the physics of everyone who wasn't the light. That's an uncomfortable thing to sit with, mostly because it asks you to stop trusting a word you've used your whole life without a second thought. Old has always meant something to you. It's meant wrinkles and rust and slow decay, and things that have been around longer, wearing that aroundness visibly. None of that transfers to something that never experienced aroundness in the first place. Here's a strange companion fact, one that seems at first like it contradicts everything just said and doesn't. That ancient light didn't leave its source unchanged. As it crossed billions of years of an expanding universe, its wavelength stretched, pulled longer by the same expansion of space that carried the galaxies apart, until light that began as something closer to visible or ultraviolet arrived. Eventually, as microwaves, cool, faint, almost unrecognizable from what it started as. That's redshift, and it's completely real, measured with enormous precision, the backbone of how we know how old the universe is at all. So the light changed, its wavelength stretched, its energy dropped. In every physical property we can measure from the outside, it is not the same light that left. And yet, in the one accounting that would actually require an interior experience of the years passing to make sense of the word changed, nothing happened to it at all. Its own proper time is still 0. It didn't gradually stretch the way a rubber band stretches while someone pulls on both ends, feeling the tension build second by second. It simply is different at arrival than it was at departure, without there being a during in which the difference accumulated. The universe did something to the light. The light didn't do anything, or experience anything being done in between. This is one of the places where the two accountings stop feeling like a pair of tidy alternatives and start feeling like they're describing something genuinely difficult to hold in a single picture. From outside, there's a whole causal story. Space stretched, wavelength lengthened, energy dropped, all of it happening gradually over cosmic time, following equations that describe an actual process unfolding. From the light's own frame, there's no gradual anything. There's an emission and an absorption, and whatever sits between them isn't a process the light lived through. It's just the space between two facts about the universe. Facts we happen to be standing far enough apart from to call a stretch of time. Some physicists, if you push them on this in person, will actually pull back a little from the claim that a photon experiences anything at all, 0 time included. The word experience implies something having a perspective, and whether a massless particle can be said to have one in any meaningful sense is more a question of interpretation than of settled physics. What isn't in question is the math. Proper time along a light-like path is exactly 0. No exceptions, derivable directly from the geometry of space-time that special relativity describes. Whether that 0 deserves to be narrated as an experience, or should be left as a bare mathematical fact with no story attached, is where careful people start choosing their words differently. I've been telling it as a story anyway, because that's the only way I know how to hold it in my head for more than a few seconds. I try to remember saying it, that the story is a translation, not the thing itself. I don't have a clean way to make those two pictures shake hands. I've tried on other nights, and mostly what happens is I end up more certain that they don't need to. Physics doesn't require the interior and exterior descriptions of an event to feel like the same story told twice. It only requires that each one, taken on its own terms, be internally consistent and match what we can actually measure. Both do. Neither one is the real version with the other one as an approximation. They're just two different valid ways of asking a question that assumes different things about who's doing the asking. I called this a chapter about photons, and it mostly has been. But somewhere in here it turned into something closer to a chapter about the word when. How much weight that little word is quietly carrying every time we use it. How much it assumes about sequence and waiting, and one moment following another, and how easily all of that assumption falls apart the instant you ask it to describe something, moving at the one speed where none of it applies anymore, where beginning and end sit in the same breath, unbothered, exactly where they started, the whole trip already over before it had a chance to be a trip at all. Push this forward instead of backward, and it holds just as steadily. Long after every star currently burning has gone dark, long after the last red dwarfs sputter out over trillions of years, whatever light manages to escape in that final stretch will do exactly what every photon before it did. No aging, no accumulated exhaustion from being some of the last light the universe ever makes. It will simply exist at its point of departure and its point of arrival, identically unbothered, indifferent to the fact that it happens to be closing out something rather than opening it. The universe doesn't grade its photons on when they showed up. Every one of them gets the same zero first light and last light alike. There's a particular kind of quiet that settles in once you've turned this over long enough, and it isn't resolution exactly. It's closer to what happens after a long note finally stops ringing in a room, not a conclusion arriving, just the absence of the last thing that was making noise. The photon that reaches your eye tonight, from a star that may not even exist anymore, carries no memory of the trip, no weight of the years, no interior record of anything at all. It is simply, finally, here. And you are the one, as you always were, left holding the years it took to get you that.